Let's say you're a new startup building the next great AI hardware accelerator. Your accelerator is a small component of your customer's overall system, and what your customer really cares about is how the accelerator improves performance of their complete system. Unfortunately, it takes forever to build and deploy a hardware prototype before you can answer this and adjust accordingly. Now we will show you how SimBricks helps you build hardware fast and agile like software. For this, we flip the process, starting with full virtual deployments early in the design, and thus getting early and continuous feedback on system performance. The first step for designing a hardware accelerator is determining how it integrates into your system. For your AI accelerator, this means how does the application load data into and out of the accelerator, and how does it coordinate computation. Typically, you start by building a simple simulation model of your accelerator. You might choose a framework like System C or just write something in your favorite language. That model in isolation is not very useful though. But with SimBricks, you can combine it with other simulators for other components in the system. Let's use QEMU to simulate a machine connected to your accelerator running Linux and your inference server application. Let's see how to actually do this with SimBricks. First off, you build your application, drivers and other software exactly as on a physical system. Here's a simple benchmark. Now, you configure your simulation with the Python-based SimBricks orchestration framework. First, you define parameters of your accelerator model. Next, you specify the software to run on the simulated machine. And finally, you instantiate and connect up your model in QEMU for the server. To run, you simply invoke SimBricks run. You can see the output of the system, including the application, as the simulation runs. Once everything works, you want to measure how the accelerator performs in a larger scale system. For this, you switch to a host simulator that more accurately models performance and enables synchronization between simulators for meaningful measurements. You then connect the server up to a network simulator with a standard network card. Next, you create a couple of client hosts without accelerators, configure them to run your client application, and also connect them to the network. Running this simulation is equally simple. With the slower, more detailed host simulator, this now takes more time, but the output is similar. Once you have validated your design, you start implementing your hardware step by step in RTL. Meanwhile, SimBricks allows you to continuously integrate simulated RTL into the complete system for functional and performance testing. SimBricks can run much more complex systems and simulations. We aim to make simple things simple and complex things possible.